day. Today we're talking about algebraic expressions. Problem number 1. What algebraic expression that models the word phrase 7 fewer than a number t? Well, 7 fewer means we're going to subtract. But who are we subtracting from who here? 7 fewer than t means we're going to start with t and then reduce it by 7. So that means t minus 7. Can you figure out which one is 2 times the sum of a and b? Well, this one doesn't have 2 times anything. It only has a sum of a and b. Here, the 2 is only multiplied by the a, so this would be the sum of the product of 2 and a and b. Here it's a plus 2 times b. This one is 2 times the sum of a plus b. Ding! Okay, so to model a situation with algebraic expressions, first you identify what it is in the question that suggests operations. Those are multiply, divide, add, and subtract. Then define one or more variable to represent the unknowns, and then represent the actions using the variables and operations. Alright, you start with $20 and then you save $6 each week. So relate. That means we're going to take the starting amount plus we're going to save some more, and then we're going to multiply the amount we're saving times the number of weeks. $6 each week, so we need to multiply by the number of weeks to know how much we're saving. So if we let W equal the number of weeks, we get $20 plus $6 times the number of weeks. And our expression is 20 plus 6W. So can you come up with an expression that models this situation? You had $150, but you're spending $2 each day. So I'm starting with $150 and I'm spending $2 each day. So that means I'm going to take away $2 times the number of days. So what did I just kind of defined D to be the number of days, and I thought through it and I said, hey, there's $150 minus $2 per day. Booyah! So evaluating algebraic expressions means substituting a number in for each variable. Then you simplify using order of operations. So problem 3, what's the value of the expression for the given values of the variables? So the expression is 7 times the sum a plus 4 plus 3b minus 8. So we're going to substitute the value in for each variable. A is negative 4, so we'll put a negative 4 there. B is 5, so we'll put a 5 there. Next, we're going to perform the operations within the grouping symbols. Negative 4 plus 4 is 0. Then we're going to multiply, since we don't have any powers. 7 times 0 is 0. 3 times 5 is 15. And then subtract. 15 minus 8 is 7. Alright, let's do B. We're going to substitute 1 in for x, and we're going to substitute 1/2 in for y. Then there's nothing inside parentheses to do, it's just 1/2, chillin'. So next is exponents. So I need to square 1/2, and that means 1/2 squared means 1/2 times 1/2. 1 times 1 is 1, 2 times 2 is 4, so that's where they get the 1/4. Now we need to add the fractions. 1/2 plus 1/4. Well, 1/2 is 2/4, and that's where we get the 3/4. Let's go ahead and pause the video and see if you can answer this question. Alright, I'm going to start writing up here. I got 2 times the difference of x squared and y squared, all divided by 3. And x equals 6 and y equals negative 3. Let's evaluate. So we got 2 times see, x equals 6, so 6 squared minus y is negative 3, so negative 3 squared, all divided by 3. Now I need to do inside the parentheses first, but inside the parentheses I got exponents, so I'm going to have to do those. 6 squared is 36, and then negative 3 squared is negative 3 times negative 3, which is positive 9 over 3. Now I need to simplify inside the parentheses. 36 minus 9 is 27. Then simplify the top. 2 times 27. 2 times 27 is 54. And then 54 divided by 3 is 18. So B, will the value of the expression change if the parentheses are removed? Well, if I was to remove the parentheses, it would look like this. 2x squared minus y squared. So now the 2 doesn't get multiplied by the y squared at all. So I think that is going to change it. So that's 2 times 6 squared minus negative 3 squared over 3. That's 2 times 36 minus 9 over 3. 2 times 36, 72 minus 9 over 3. 72 minus 9 is 63 over 3, and 63 divided by 3 is 21. So heck yes, the value changes if you take out the parentheses. That's why we got to be real careful, pay attention to detail, make sure we're copying down the problem correctly. Okay, so in football, a touchdown is worth 6 points, and an extra point kick is 1 point, and a field goal is 3 points. What algebraic expression models the total number of points that a football team scores in a game, assuming each scoring play is one of the 3 given types? Suppose a football team scores 3 touchdowns, 2 extra point kicks, and 4 field goals. How many points did the team score? So first we need to relate. We're going to get 6 points for each touchdown. So that's like 6 times TD, plus we're going to get 1 point for each extra point kick, plus we're going to get 3 points for each field goal. So that's kind of what we did here. Points per touchdown was 6 times the number of TDs, plus points per extra point kick, that's 1 times the number of extra point kicks, plus points per field goal, that's 3 times the number of field goals. Let's define some variables. Let t equal the number of touchdowns, let k equal the number of extra point kicks, and let f equal the number of field goals. And we get 6 times the number of touchdowns plus 1 times the number of kick extra points plus 3 times the number of field goals. So 6t plus 1k plus 3f. You could just write 6t plus k plus 3f, and that would be fine. Now, if we score 3 touchdowns, 2 extra points, and 4 field goals, that would mean t equals 3, touchdowns is 3, k equals 2, and f equals 4. So when we plug in, 6 times t is 6 times 3, plus 1 times 2 for 2 extra point kicks, and 3 times 4. Then we're going to multiply each one of those, and then add, and so our team scored 32 points. Why don't you pause the video and see if you can answer this question right here. In basketball, you can score by making a 2-pointer, a 3-pointer, and a 1-point free throw. What algebraic expression models the total number of points that you can score in a game? Alright, well, let's define some variables. Since 2-pointers and 3-pointers both start with T, I can't really use T. So I'm just going to say, let's let x equal the number of 3-pointers, y equals the number of 2-pointers, and z equals the number of free throws. So then our score would be 3 times the number of 3-pointers plus 2 times the number of 2-pointers plus 1 times the number of free throws. And then if the team makes 10 2-point shots, so that means that y equals 10, 5 3-point shots, so x equals 5, and 7 free throws, so z equals 7. How many points did they score? So I'm going to substitute those in to evaluate. 3 times 5 plus 2 times 10 plus 1 times 7. And I'll multiply. 3 times 5 is 15. 2 times 10 is 20. 1 times 7 is 7. Then I add those together, and the team got 42 points. And the secret phrase for this lesson is hula hoop. You know it. I said it. Hula hoop. Alright, here's some notes. An expression that is a number, a variable, or the product of a number and one or more variables is a term. So this is what a term looks like. It can be any one of these. It can be a number, it can be numbers and variables, it could be numbers and more than one variables. Each of these is called a term. A coefficient is the numerical factor of a term. So here -4 is the coefficient, and 7 is the coefficient of this one, and -6 is the constant coefficient. A constant term is a term with no variables, so -6 would be our constant term. You can add terms to form longer expressions. This expression has 3 terms. Like terms have the same exact variables raised to the same powers. So in this expression, like terms are 3x squared and 5x squared. They have the same variables raised to the same power. 9y cubed z and -4y cubed z are like terms because they have the same variables to the same powers. You can simplify an expression that has like terms. You combine the like terms using the properties of real numbers. And then you're simplifying. And it's all wonderful. And we love it. So here's a review of all these properties that we can use to simplify. The definition of subtraction is subtracting b is really adding the opposite of b. The reason we want to do that is because once we change it to adding the opposite of b, we can use all of our addition rules. A divided by b is the same as a over b. This means a divided by b. It's the same as a times 1 over b, but b can't equal 0 because you're never allowed to divide by b. I mean, you're never allowed to divide by 0. I'm tired. Sorry. The distributive property for subtraction. A times b minus c is, when you distribute it through, a times b minus a times c. And I won't go through all of these, but these are properties. You should know them. Put them in your notes. Boom. Alright. Combine like terms. What is a simpler form of each expression? So the first thing I'm going to do is I'm going to look and see if I got like terms. I got 7x squared and -4x squared, and I got 3y squared and 2y squared. So let's see how we're going to use our properties to simplify this. We identify our like terms. Commutative property lets us move them close to each other. The distributive property lets us put the coefficients together of the same like terms, and then we can simplify within the parentheses, which is called combining our like terms. 7 minus 4 is 3, 3 plus 2 is 5, and now we don't have any more like terms. So this is as simplified as we can get. How about this guy? So we're going to use the opposite of a sum and a distributive property. So the distributive property means the negative comes through to the 3k, the negative comes through to the m, and then 2 times k is 2k, 2 times negative 4m, negative 8m. Then we're looking at like terms, negative 3k plus 2k, negative 3 plus 2 is negative 1, so that's negative k, negative 1m, and negative 8m is negative 9m. Alright, pause this and try A and B here. Alright, so I'm going to use the commutative property to put my j squared over here by my j squared. Negative 4j squared plus j squared minus 7k plus 5j. Now the 5j is not a like term because it's not raised to the same power as these two are. But this is like negative 4 plus 1, which is negative 3j squared. And then I'm going to use the commutative just to throw the j closer to the j squared. So plus 5j minus 7k. Alright, on B. Distribute the negative through. So negative 8a minus 3b plus distribute the 10. 10 times 2a is 20a. 10 times negative 5b is negative 50b. And then I'm going to combine my like terms. I've got negative 8a, positive 20a, that makes positive 12a. And then I got negative 3b and negative 50b. Those add together to make negative 53b. Those are the examples. That's your lesson. Go ahead and work on practice 1.3 and then get onto that formal write-up 1.3. Talk to you later. Bye-bye. Toodles!